Welcome to your Algebra 2 lesson over 3.2. Today we're going to talk about how to solve systems of linear equations algebraically. So you're going to solve using substitution and elimination, two algebraic methods. Okay, substitution method, basically you're going to take one of the equations and solve it for one of the variables, and then substitute that expression into the other equation and solve for whatever variable remains. Once you get a value for that one particular variable, you're going to be able to plug that in and solve for whichever one remains to be found. It's much easier to see in action than describe in words. So let's look at an example. Alright, so we're going to solve the system using the substitution method. Our first equation is 2x plus 5y equals negative 5. Our second equation is x plus 3y equals 3. Because we have just a plain x term, that's going to be the easiest variable to solve for. So we're going to solve for equation 2 for x, because all we have to do is subtract the 3y over. And so to get our revised equation 2, we subtract the 3y, and we get x equals negative 3y plus 3. So now what we're going to do is we're going to take this expression right here, this negative 3y plus 3, and we're going to substitute it right here for x. So we're going to take equation 1, and here where it has x, we're going to put in negative 3y plus 3. So we're going to have 2, and then in parentheses, negative 3y plus 3 plus 5y equals negative 5. And the beauty of that is that gets us an equation just in one variable, so we can solve that. So let's see, we would distribute the 2, and that would give us negative 6y plus 6 plus 5y. That would give us negative y equals negative 11 when we solve for start solving, and then divide by negative 1, we get y equals 11. Okay, so now we have our y value. We need the x value. You can plug it into either original equation or the revised equation 2. Probably would be the easiest because it's x equals negative 3y plus 3. So just a matter of substituting in the 11 and then simplifying there. So negative 3 times 11 is negative 33, plus 3 is negative 30. So our solution is negative 30, 11. If you want to check it, you can check it by substituting negative 30 for x and 11 for y in the original equations. So we can check that 2 times negative 30 plus 5 times 11 equals negative 5. We can also check in the other equation that negative 30 plus 3 times 11 equals 3. So let's see, negative 60 plus 55 is negative 5, so that works. And then negative 30 plus 33 is 3, so our second equation works. And so our solution checks, and we are happy, yay, negative 30, 11 is our solution. If we were to graph these two equations, that is the point where they would intersect. All right. The elimination method. This is going to be where your goal is to get opposite coefficients in front of one type of variable so that you can add them up, the two equations up, and that variable disappears. So you're going to multiply one or both of the equations by a constant to obtain coefficients that differ only in sign. In other words, they're opposites of each other of one of the variables. Then you're going to add your two equations together and solve for the remaining variable, and then you're going to substitute that value back into an original equation and solve for the variable you eliminated originally. Alright, again, easier to see in an example. So here's our two equations, 3x minus 7y equals 10, 6x minus 8y equals 8. So looking at this, let's see. If we multiply the first equation by negative 2, that will give us negative 6x, and then in the second equation we have 6x, so we could add the two equations together and eliminate the x's, which is why this is called elimination. So let's take this top equation and multiply by negative 2, and you want to show that. You can write it above an arrow, just draw a little arrow and put times negative 2, and so we have negative 6x plus 14y equals negative 20. And then we just recopy our second equation, 6x minus 8y equals 8. And then we add the two together. Negative 6x plus 6x is 0, so those eliminate. 14y plus negative 8y is 6y. And let's see, what did we have there? Negative 20 plus 8 is negative 12. So 6y equals negative 12. Divide both sides by 6, and you get y equals negative 2. Now we need to know what x is, so we're going to take that y equals negative 2 and put it into one of the original equations and solve for x. Let's use equation 1. So we have 3x minus 7y equals 10. So let's substitute that negative 2 in for y. So 3x minus 7 times negative 2 equals 10. So that would be 3x plus 14 equals 10. And then subtract 14 from both sides. We get 3x equals negative 4. Divide by 3, we get x equals negative 4/3. So our solution is negative 4/3, negative 2. All right, standardized test problem and also a word problem. To raise money for new football uniforms, your school sells silk screened t-shirts. Short sleeve t-shirts cost the school $5 each and are sold for $8 each. Long sleeve t-shirts cost the school $7 each and are sold for $12 each. The school spends a total of $2,500 on t-shirts and sells all of them for $4,200. How many of the short sleeve t-shirts are sold? All right, let's write a verbal model for this situation. Short sleeve cost times the number of short sleeve shirts plus long sleeve cost times the number of long sleeve shirts equals the total cost. So 5x plus 7y equals 2,500. Our second equation is going to be the money that the school makes. So short sleeve selling price times the number of short sleeve shirts plus long sleeve selling price times long sleeve shirts equals the total revenue. The profit's going to be the difference between the two, but that's a whole different story. We want to know how many of each type of shirt is going to be sold. So we've got the total cost equation and the total revenue equation. Now we need to do some solving. Substitution's not going to be easy, would not be easy because there's not a variable with a coefficient of 1 or negative 1. So we really want to use the elimination method here, and neither equation's necessarily, or neither variable is necessarily easy to solve for. So let's go ahead and eliminate the x's. And so let's see, we can multiply the top by negative 8 and the bottom by 5. So that way we'll have a negative for one equation, a positive for the other, and we should get this same coefficient other than the sign. So 5x plus 7y equals 2,500 times negative 8 gives me negative 40x minus 56y equals negative 20,000. 8x plus 12y equals 4,200. I multiply by 5. That gives me 40x plus 60y equals 21,000. So I add the two together. My x's are eliminated. I get 4y equals 1,000. Divide by 4, I get y equals 250. So far we know 250 long sleeve t-shirts. So let's plug in 250 for y and solve for x. So 5x plus 7y equals 2,500. Substituting 250 for y gives us 5x plus 7 times 250 equals 2,500. 7 times 250 is 1,750. Subtract from both sides and you get x equals 150. Okay, so when we subtract, we get 5x equals, let me see, what would that be? 750, and then divide by 5, and that would give me 150, not 1,050. That's funny. 150. Okay. So the school sold 150 short sleeve t-shirts and 250 long sleeve t-shirts. So the answer is going to be C. All right, we're going to solve linear systems with many or no solutions. All right, let's look and see what happens when that goes on. All right, our first system is x minus 2y equals 4, 3x minus 6y equals 8. Because the coefficient of x in the first equation is 1, we're going to use the substitution method and solve for x. So let's see, x minus 2y equals 4, so x equals 2y plus 4. So when we look at our second equation, 3x minus 6y equals 8, we're going to substitute in 2y plus 4 for x. So 3 times 2y plus 4 minus 6y equals 8. That would give me 6y plus 12 minus 6y equals 8. Well, 6y minus 6y zeroes out, so I'd have 12 equals 8. That's a false statement. It's never true, so there is no solution. So already we know there's no solution. There's no way to please both equations at the same time. All right, for B, because neither coefficient is 1 or -1, let's use the elimination method. So we're going to multiply the top equation by 7 and the second equation by 2, as that'll give us opposites in front of our y variable. So when I multiply the top equation by 7, I get 28x minus 70y equals 56. I multiply the bottom by 2, and that gives me negative 28x plus 70y equals negative 56. I add everything together, and I get 0 equals 0. Well, that's always true. So because the equation 0 equals 0 is always true, there are infinitely many solutions. Okay, guys, that's it for your examples. Try the problems to try on your own. Thank you for taking your time to take good notes and to listen to the lesson. If you need to, go back and listen to part of it again, and I will see you in class. Have a good day.